Hey guys, today's topic is speed and velocity. So when we're talking about motion, there are two types, linear and harmonic. And harmonic has to do with waves, and we'll talk about that next semester. But motion is a change in position in a certain amount of time. So linear motion just goes from one place to another without repeating. So this goes into our topics that we've discussed with distance and displacement, and it also goes into time, speed, and acceleration. So just as a review, remember a vector quantity has a direction and a magnitude or a number. It tells you where you're going. As opposed to scalar, scalar is just a number or just a magnitude. So we talked about distance being, your total distance from A to B, and then displacement being like your Superman jump, you're seeing that shortcut. Well, even though they're kind of similar, they're a little bit different, and so that's the same thing with speed and velocity. So speed is a scalar quantity. That means that when somebody tells you the speed is just a number, it's not going to tell you where you're going. So this is thought of as a rate at which an object moves. So for example here, let's say you have a person walking 1 meter per second. So every second they walk 1 meter. So they cover 5 meters in 5 seconds. Person B here down in the second picture, well, they're walking 3 meters per second. So every second they cover 3 meters. So what can you tell me about the speed of each person? Well, we find that a fast-moving object has a high speed if you cover large distance in short amount of time. So for example, the second person here has a faster speed because they were able to cover more distance in the same amount of time. Okay, slow-moving objects are not going to cover as much distance in that same amount of time. Velocity is a vector quantity. That means not only are you given a number, but you'll also be given a direction. And a good way to remember this is V, velocity for vector. And you remember it starts with V, so hopefully you remember that. So we have to keep track of the direction where they're going. So classify the following quantities as speed or velocity. So for example, number 1 here tells me 55 miles per hour east. So it gives me a direction, so I know that has to be velocity. As opposed to the second one, 34 kilometers per minute, that's just telling me how fast I'm going, my rate. That's just speed. Go ahead and pause the video and see if you can do the rest on your own. So we find out that the third one, 1 mile per hour is speed, 289 meters per second west, that's velocity, giving me a direction. 45.2 meters per second, that's just giving me a magnitude, a number, so that's just speed. So average speed versus instantaneous speed. So instantaneous means at that moment. So if they're asking for instantaneous speed, I just want it at that instant time. So you might be traveling for an hour, but I just want that instantaneous speed at the 30-minute mark. So that's instantaneous. As opposed to if I wanted the average, during that hour trip, I would take the average of your entire distance and your time. So we have two formulas here. Average speed equals the distance traveled over the time of travel. So this would be total distance traveled, total time of travel. Average velocity is the change in position. And so this little triangle means change. That means you have final minus initial position. So you might end up at 100 meters, but you started at 50 meters. Okay, that's my change, and that's my displacement. We've talked about that over your time. So while on vacation, Lisa traveled a total distance of 440 miles east. So this tells me she's giving me a velocity here. Her trip took 8 hours. What was her average speed? So to find speed is just distance over time, my total distance. My total distance was 440 miles, and my total time was 8 hours. So that 440 divided by 8 gives me 55 miles per hour. And because it is speed, we only include the magnitude of their number. So same problem, but now they want you to calculate average velocity. So we take our distance over time. So same process, but now we include the direction because velocity has to have a magnitude and a direction. So to determine the speed of an object, you need to know the distance traveled and the time taken. So that seems pretty simple. So the good thing with this formula is that you can rearrange it to determine the distance traveled or the time it took to travel that distance. So for example here, the first equation we've been dealing with is d over t, distance over time, which will give me my speed. If we arrange that formula, d equals v times t, gives me the distance, how far I went. And I could also figure out time. So I could do the algebra here real quick. V equals d over t. Let's say I wanted to find distance, well then I would just cross multiply. And so d equals vt. Okay. Let's say I wanted to find time. So up here, v equals d over t. I could either, I could continue doing the cross multiply, so d equals v over t. And to get t by itself, I divide both sides by v. So I get d over v equals t. Those are different ways to rearrange the formula. Because on your test, you would only be given this formula. You would be expected to do the algebra to find these two. So let's look into some practice problems for speed and velocity. So a bike moves 50 meters in 5 seconds. Calculate the speed of the bike. So with these problems, it's very good to underline your information. So they give me distance, which is 50 meters. And they give me time. They're trying to find speeds. Okay, so distance, speed, right here, is distance over time. So it would just be 50 divided by 5 meters in seconds, which is equals to 10 meters per second. And that worked out. Speed does not have a direction, so it's just 10 meters per second. Our car travels 60 meters per second. So that's giving me my speed for 60 seconds, that's time. Calculate how far. How far is the distance traveled? So I'm looking for d. So we're giving the formula s equals d over t, but I'm trying to find d. So what I'm going to do is I'm going to plug in my numbers first. So s is 60 meters per second. My distance, I don't know my distance, so I'm going to keep it as d, and my t is 60 seconds. So to get d by itself here, I just cross multiply here. So 60 meters per second times 60 seconds is equal to 3,600 meters. Our car travels 200 miles, so you should underline miles, which is distance, in 8 hours, which is your time. Calculate the car's speed. So speed equals distance over time equals 200 miles over 8 hours. So 200 divided by 8 is just 25 miles per hour. A car travels 200 miles north. So it's giving me a direction here. This is a direction in 8 hours time. What is the car's velocity? So velocity is distance over time as well. My distance is 200 miles north over 8 hours. So my final answer should have 25 miles per hour, but include the direction because it's asking for velocity. Final problem here, a car travels 20 miles north, so that's the direction, then 4 miles south, another direction, in 8 hours time. Calculate the car's velocity. So this is, we have two different distances. That means we have to find our displacement here. Final minus initial. So V equals delta D over T. A change in position. So I went from 20 miles north and then 4 miles south. So I'll have to take that off. Remember, if we talk about vectors here, you went 20 miles north and then you went 4 miles south. Oops. So you have to take away that. 20 minus 4 is 16. Then my time was 8 hours. So 16 divided by 8 equals 2 miles per hour north.